It's going to be a collaborative hackathon. It's pretty loose. We are really excited for everybody to be here. I do want to mention that we have a code of conduct, since this is a ByCode Alliance event, and we hope that everybody adheres to it. If you want to look at it, here's our QR code for this. Thank you for being here, and I just want to say, be kind. We're going to run into a few different types of all of our tooling. It's all bleeding edge, so I expect bugs. Actually, bugs will be really great because that's something that we can fix. It's an opportunity. This is the Wi-Fi code. Pausing for a second so that everybody can grab it that's here in the room. This is my favorite part, which is getting to thank Ralph and our host and sponsor, Microsoft. So I also want to thank all of the volunteers. There are a lot of different folks that came together to put this event on. And honestly, it's more than just this list. It always is. So thank you for helping us get together for the first time. This is our rough schedule. We just had breakfast, so that this just happened. I'm just kicking things off. I'm going to pass over to Till. Then up next is going to be Alex, and then we're going to move on to breakouts. And obviously, this is a rough schedule because we didn't finish typing out Till's name, so sorry about that, Till. And that's kind of the idea, is that this event is going to be what you make out of it. We want to have the tools and everything reflect what we've been working on for the past couple of years. And the only way to do that is to get a diversity of users, people contributing and collaborating. So you're as much a part of the schedule as anything else. Till?
Good morning, all. I am Ty, the person formerly known as Till. I've just been renamed. And I wanted to give an overview of what the Bytecode Alliance is, how it works, why we founded it, and all of that. And it was there were slides, and it would have been dazzling. But I actually decided not to give exactly that intro and do something more ad hoc. So I don't know. This might be a little bit unstructured. When Dan Goleman came to me in 2018 and back in a galaxy far, far away at Mozilla, and told me about how he thought we really should not only focus on WebAssembly inside the browser, but also on bridging that gap to outside the browser and making use of this technology in places where others had looked into, but we, as the WebAssembly and Rust team at the time at Mozilla, in Mozilla Research, hadn't really focused on. He pretty quickly convinced me that, yes, it made sense to do that, and he worked on what ultimately became WASI in the next year. And based on that announcement and based on conversations we had around all of this, it was very quickly clear we had something very big going there, huge amount of interest in across big parts of the industry. And we realized this can be much, much bigger than running different languages on the web and making websites and applications faster. So we realized quickly, this is too big for any organization to go it alone, let alone our small team. And so we realized we needed to have an organization around all this. And that is what ultimately became the Bytecode Alliance. And that's how we are all here now. And we had big ambitions. I mean, we called this event Componentize the World. And there's a reason behind that. We do believe, and that's still the ByCode Alliance is very much about bringing a new way, it's in our mission statement, creating foundations, new foundations for building software. And if anything, over those last few years, the likelihood of success in that has only increased over time. Back then, it seemed like highly ambitious, but it seemed like we had a shot at making it work. And now it seems like it's actually looking really good. That also means, and that meant, it was very quickly clear, we needed to build the right kind of organization. We needed to make sure that the ambitions would have the right context, but also we would set up the right governance structures for enduring the eventual sort of onslaught of people having interests, big organizations, small organizations, competitors, being able to work together in the right ways and building the right community. And so it took a while to sort that out. That's why between the announcement of the ByCode Alliance in November and then actually admitting new members, it took more than a year and a half. But I think we succeeded in that. I think we built the right governance structures. We built the right foundations for creating an excellent community. And the reason I decided to not show my slides, not go into all the details I wanted about here's what the governance looks like and so on, is that it's for reasons I can't go into there. It's the building the right community is very much top of mind for me. And what I want to appeal to you all on is not just today, not just in this room, but in general. Some of us have different priorities. Some of us are competitors. Some of us actively dislike each other. And that is all totally fine. And we built an organization that is meant to endure all that. But it only works if throughout all this, we remember that pushing out our elbows is not the right way to achieve anything. Being intolerant to other people is not a way to achieve anything we want to achieve. Whether you deeply believe in the goals I just outlined or think, well, we'll see, I'm just interested to learn a bit more about it. All of this will be way more successful if we are ideally kind and open-minded to each other, but at the very least respectful and polite. And so that is what I want to appeal to you all for today and in general. Be kind to each other, be excellent, be tolerant, but not of the intolerant, and help us build a future that we can all be proud of. But also have a lot of fun with componentizing the world, because that is first and foremost what I think is really exciting. I really do believe that we have the opportunity to change the way huge parts of the software ecosystem are built and to be more resistant to kind of challenges of the future in a kind of increasingly hostile world around malicious attacks on the systems we are building and regulators who demand us, all of us, to do better in the face of this. And I think we can do this. And I'm incredibly proud that we have so many people here for our inaugural public event of the ByCode Alliance and who want to learn about this and or help us build this future. So welcome all of you here, and I'm excited for the rest of the day. Thank you all.
until I actually see things show up. That's a green line. I'm just gonna. All right, doing all right. All right. Good morning again, everyone. I think I'm live on the internet, so I think people can actually hear me now. So I'm going to give you a whirlwind tour of components, how to do that a little bit in Rust, and I think we'll hear more from Guy later about JavaScript and things like that. So this is just one way to do things. It's a little bit of an intro to the tool chain. So first thing I want to show off, I'm going to be doing some live demos, so we'll see how it actually pans out. But first thing is cargo component. So this is probably one of the main entry points that everyone's going to be using for the Rust guest program side of things. So if you're writing a Rust component that you're compiling to WASM and then running, you're going to be using cargo component. So this is at github.com, ByCode Alliance, cargo component. And then we can copy and paste the install instructions down here. I think I've already done that here. And now we got that. So I would recommend a lot of this tooling we'll see today, try and have the most up-to-date versions. This is one where we tried to make sure everything's working in concert right now, but as Bailey was saying, this is there's a lot of stuff still working in progress. So try and make sure everything is up to date. That'll give you the best chances everything is actually working together at this time. If you're watching this in the future, a few days from now, sorry if it's now broken at that point. But for now, for today, if everything is at the latest, it should all work together. So let's start out. We can just do a nice little cargo component new. This is very similar to cargo. Make a new project. I didn't give it a name. We'll give it a name. Now we have a new project, and you'll find out that it's actually pretty similar to cargo. You've got source files. If you take a look at this, that's nice source main. Oh, there's this nice little macro thing. I'm going to make this bigger. Oh, no. All right. Can everyone see that all right? Anyone? That is. Does anyone else know how to change color? Because honestly, I'm not actually sure how to change color. I'll highlight different stuff later. Cat. Oh, there we go. All right. There's our nice thing. I'll highlight it to make it even harder to see. But anyway, so we're going to build. This is going to take a second. So I'm going to talk while this is doing this. So this is very similar to sort of the cargo build process. You have cargo component build, you got cargo component publish, you got cargo component build -- release. This is kind of just how we get components out of the system. So what this is doing behind the scenes is we've seen wit bindgen there near the bottom. I'm going to describe that in just a little bit. But for now, we've now got our component at this nice fancy path, which is kind of where you would expect a lot of Rust binaries to take a look at. So this brings me to my next piece of tooling, which is called WASM tools. So this is at ByCode Alliance or github.com/ByCode Alliance/WASM tools. This is a CLI test suite intended to generally debug stuff. So this is a very low-level tooling. You unlikely use this on a day-to-day basis, but if you're curious to poke around, if you're curious to kind of see how things work, how the sausage works under the hood, this is a great suite to take a look at. So this is published on Crates.io, so you can cargo install it, and I think I've already got it here. I could definitely type today. All right, so this WASM file that was created is an actual component. So if we try and validate it, it's going to say, well, the component model is not enabled. So we'll turn on component model. Oops. Component model. Now we validated. There's no output, so it looks like it's good. So we can take a look at this. We can actually print it. So this is the S expression format. This is kind of the raw textual format. So this is effectively a way for us humans to take a look at the binary format under the hood. But we can see this thing is a component. There's lots of stuff in here. This is core WASM now at this point. We come to the bottom. There's some more component stuff. There's a lot going on here. We're not going to go too much in the details here, but let's actually try and run this thing. So to run this, you need a component runtime. There's kind of two major component runtimes we're going to be talking about today. One is WASM time, and one is JCO, which is actually running components on the web. I don't have a web browser set up to do this just yet, so I'm going to show you WASM time. So WASM time does not have this in its currently published releases, so I recommend checking it out. The current main or the release 13.0 branch, that'll have all the good stuff. I think I have a pre-built version here. There we go. And if I try and run this component, it's not going to, yep, right, it's going to want some features. So this is a component model is off by default right now, so I got to enable it with some features. Typed everything right. All right, and we saw no output. That doesn't make any sense because this thing says it's printing hello world. So this is a small bug which we're going to fix in the near future. So take my word for it, and all we got to do, it's merging on Monday. So add a nice little sleep there because that's how you fix all your programming issues. And there we go. Now we see it printing out. Ignore the fact that it's sleep. This is deprecated. Don't worry about that. Anyway, so this is if you're running in WASM time today. It's worth it to know that if you are printing out output, you're probably going to have to sleep in your program for a little bit. That'll get fixed on Monday. But otherwise, we now have an actual component. and to prove I'm not actually doing anything weird, or I don't. This is not pre-canned. This is a demo. Oh, I'm gonna throw in stuff that my terrible typing, and we can actually. Oh, gotta build it again. Build it again. Run that. All good. So this is sort of a whirlwind tour of just how to get components up and running. In my demo today, I'll actually show you a way to run it. We'll run it with Jco on the browser as well. I'm not going to do that just now, but I do want to go into now something else. So this call right here, which I'm going to do this and say that call. So this is a cargo component specific thing and leads me into my next thing I'd like to talk about, which is WIT bindgen. So WIT bindgen is kind of how a lot of this is working under the hood in the Rust language, and you'll also find this in many other languages as well. So this is at ByCode Alliance WIT bindgen on GitHub, and the WIT bindgen tooling is intended to be guest bindings generation for various languages. So I think I've got a checkout of that over here. There we go. Oh, I got target. I think I did. There we go. All right. So WIT bindgen gives you a suite of languages which you can generate for. So the cargo component stuff kind of bakes in WIT bindgen for you. So you're automatically using Rust. You're probably not going to use WIT bindgen itself if you're using cargo component. But if you're curious about looking under the hood, seeing how the sausage is made, this is kind of to explore things. If you're integrating this into other languages such as C or TinyGo right now or TVM Java, you might be running this by hand because this is where the tool chains for those languages aren't quite fully as integrated as cargo component just yet. So you'll probably be invoking this by hand. But to show you a little bit about what's going on here, this is using WIT, which I actually have not pulled up a link for. I'll do that later. So we can have WIT files are the way to describe types in the component model. This is a textual representation which is intended for us developers to read and write. So it's got comments, it's got white space, you can order things however you want. It's intended to be nice and user-friendly. So we can make a little thing right here. Whoops. I have great names for everything. All right. Components are organized into worlds. This is where a component, like a world effectively describes what can be imported into component, what can be exported from a component. So here, let's just add some names. Let's just have some functions. Let's have some types. And then let's actually take a look at what's going on here. This is how, oh, whoop, right. I got to do this. Let's do, there we go. So that -- stubs is just an implementation of this. You don't have to worry about that with the cargo component. But the idea here is this is generating Rust bindings, which we can then use this world for. I'm going to make this pretty. And so here we have a whole bunch of generated code. This is intended to kind of be the bridge between your Rust code, the actual kind of canonical ABI of the component, and the actual source language. So we can see this is what you are supposed to write. You are supposed to write this function called bar, which corresponds to this export called bar, and it returns a string. This is a fancy Rust macro thing, but that's just a general standard library string. There's nothing special about that. And then if you actually wanted to call this this foo function here, if I find it, it's just generated bindings up here. So this says, it doesn't actually take any arguments, but all it does is it kind of under the hood calls this WIT stuff internally or core WASM stuff internally. So that this is, you can explore some generated code this way. It's kind of if you want to take a look under the hood. Again, you probably won't be using this if you go through cargo component because part of this, what do I call it this. This macro invocation right here is actually calling WIT bindgen under the hood for you. And this is actually taken care of, if we take a look at cargo toml, you can have your own dependencies for cargo component. You can have your own WIT dependencies with cargo component. I won't go too much into that here, but all of that is handled and that all kind of gets assembled by cargo component for you. So when cargo component is running WIT bindgen, it kind of has all that under the hood. And I think that covers a lot of what I wanted to say. So there's other stuff. The other things that cargo component can do is also publishing from a registry. So this is where we're in the very early days of publishing components to a registry, publishing WIT definitions to a registry. So for example, the WASI interfaces are now on the registry and in at least a prototype fashion. So if you want to have more information about that, you want to find Peter. Peter, can you raise your hand? There is Peter over there. Peter has more information about publishing, so he can kind of go more into that. We probably won't do a ton of it today because it's a little bit in sort of a preview state, but Peter has a lot more information on that. I'm going to give more Rust stuff after this in the kind of the breakout sessions, so feel free to ask me questions there. Otherwise, I think that's a general whirlwind tour, unless anyone can shout out something that I totally forgot, and I can try and go over it really quick. Right, yes, this package thing, that's just generally organization. So for a lot of WASI stuff, you'll see like WASI:CLI. If you're a company, you'll see like Fermion:HTTP or or whatever, like you'll see Fastly: something. So this is, I just kind of put in words there. I don't take this as an example. I'm not a good trendsetter with this. That's just words. Anyway, but yeah, you can ignore that. All right, so I will hand it off back now after doing a whirlwind tour. Yeah, definitely. Oh, right, Guy. I want to introduce Guy now, works at Fastly, and Guy will show us the JCode toolchain and running with components of the web when JavaScript-related stuff.
Check, 1, 2. All good? All right, so I'm going to be talking to you about the JavaScript component story.
Video's not. Oh, you're not plugged in. Oh, here.
Wrong one.
Wrong one.
All right.
That one. I need to hear you. Okay.
Have we got visuals? Just about. Okay, so
Maybe click yes or pass. Sorry.
great. Yeah, so the JavaScript toolchain. This is how you work with WebAssembly components in JavaScript. We're going to be doing a session on that. If you're interested in the topic, come along. We'll be going through some example material. You don't need to go through exactly the examples that we're going to be going through. If you want to try things out, it should be a relatively good beginner journey. But if you're interested in other aspects of JavaScript and the component model, you're welcome to go through whatever interests you, and we'll be around to answer questions and help go through that story. To explain what the JavaScript toolchain is for WebAssembly, it's the following tools. On the actual host side, so this is running WebAssembly components in JavaScript, we have this tool called JCode and JCode transpile, which will convert a WebAssembly component into something that you can run inside of a Node.js or a web browser. And so you can just sort of take that component, transpile it, and run it in a web environment. We have the Preview 2 shims library, which is a very experimental implementation of WASI Preview 2 running in JavaScript environments. And then the flip side of this coin was the actual JavaScript guest. So this is if you're a JavaScript developer and you want to write a component with JavaScript, you can use this componentized JS approach to write JavaScript code that gets turned into a WebAssembly component that can run in all these different component environments. There is also some APIs if you're interested in integrating JavaScript component tooling into other places. There's a bunch of contribution opportunities here, and that I think would be a huge outcome of this event is if people are interested in taking some of these tools into other places and seeing what they can do with it. There's a lot of scope for early contribution here, and even just the beginner feedback is what I'm looking for personally is seeing how we can improve some of these workflows. But with these JCode APIs, it's easy to sort of build plugins for components in JavaScript build tools and things like that. So as Bailey mentioned, this is experimental work. This is us kind of bringing these sort of models out to more and more users. And your feedback is so critical to this process. So there are no stupid questions. There are only issues that will get a slightly rude comment and close very quickly. But please feel free to ask the questions, and knowing where the confusions are is a huge help to us. So you're helping us tremendously just by trying these things out. So thanks for being here. And yeah, I can go through very briefly what the transpile workflow looks like for JCode. So I wasn't planning to do an initial demo for this, so we'll see how it goes. But here's how the command works. You run JCode transpile, and you point it at a component, and you give it an output directory, and it'll output a JavaScript file that you can import inside of a JavaScript module and use it with that component high-level rich interface where you can call the methods that you want and have that sort of nice interface that you can run. If you're not familiar with Node.js, that will be a prerequisite for a lot of the JavaScript stuff. So make sure you have Node.js installed. But we'll go through all that in the setup. If you don't, if you do, that's obviously ideal. And what Transpile gives us is a conversion of this is what I'm currently using for how WebAssembly components can be represented in a nice little visual, because it's WebAssembly on top of WebAssembly. But you turn these WebAssembly modules into graphs of WebAssembly modules and JavaScript. So let me actually give a very quick demonstration of that. So the first thing we're going to do once we've got the tooling set up is we're going to just verify that tooling's working by running jco run. And the exercises repo that I'm going to have you all clone is has got two folders, one with some WebAssembly commands and one with some WebAssembly reactors. And that way you can kind of have these existing components to try and use in JavaScript environments. The toolchain test is going to be jco run, which is a command runner similar to it's basically like the POSIX sort of main style of execution. And jco run can be pointed at a command. And I've got like a Rust calce called chara, which I found on crates. And you can do say componentize, and it'll output. So we can see that we're running a component that was compiled from like a Rust library that would typically be a native application, but it's running on Node.js, and it can also run in the browser. And if you want to try the browser examples, you can. It's kind of take the exercise where you want to take them. So what exactly is this doing? Well, it's using jco transpile underneath. So let's try and transpile that command. And we're going to output it into a folder called chara. And it generates all these files for us. So a lot of it is types. It's making sure that in your VS Code editor, you're going to have good types when you try and import this thing. And then the actual main file here is a JavaScript file that represents that command component. So let's create a test file that can load this up. Sorry, this is what I had from earlier. And I can import, every command exports a run interface. So I can import the run interface from that chara.js file that I just created, from. And the run interface has a run function, and I can call run.run. And that's basically how you run these commands. The command itself needs to be parsed arguments. And so I'm not doing that in this case, but at least I can verify that I can run that command and get the help output now when I run node against that test I ran. So that's just the command interface being run directly, and you can understand what jco run is doing there. As I said, the other side of this is the actual JavaScript guest language, where you're creating a component from JavaScript. And for this, you start with a with world definition that you're creating the component to. You write the JavaScript that matches that with world definition, so the interfaces and the functions, and you write that in a JavaScript file with its associated exports. And then we use Componentize.js to put together a WebAssembly component, outputs a WebAssembly component that has that JavaScript bundled along with the JavaScript engine, and you get this component that's now fully portable and embeddable in any way you want to run that component. So that's going to be the next thing we get onto in the exercises. And have I got time to do a quick demo of that, Bailey? How we're looking for time? Otherwise, we'll pick it up in the exercises. We've got time?
Yeah, do demo.
All right. So just to show you very briefly, like for example, if I wanted to write a command like I just ran earlier, but I wanted to write this command in JavaScript as a component. So a command is obviously going to have a run interface, which is going to have a run function. Sorry, I had this from earlier, so I'm going to remove this as well. And in the run function, I can then just log a message and say hello components. So that's a very simple hello world for a command that I should be able to run. And to run that command, I'm going to build that component from that command file. I'm going to say jco componentize command.js. I'm going to point it at my local wid folder. And I'm going to say that the world name that I'm building for, because you always build a component to a component world, a wid world. I'm going to point it at the CLI WASI CLI command world, and I'm going to output the command.wasm that I created. And so there's one thing I forgot to do, which is I want to enable standard out because I'm using console.log. So let's enable that as well. And that gives me a command.wasm, which is now a component that has JavaScript and a whole JavaScript engine inside of it. And we can use that same jQuery run to run that command.wasm. And you can see that it's running that JavaScript inside of that component. So this is actually running JavaScript on JavaScript. I'm running SpiderMonkey on Node.js. And it also works in the browser. So that's Componentize. So you can create JavaScript guest languages to any world from any ES module. You can implement commands and reactors and HTTP proxies, which is obviously the much more interesting use cases. It's based on the SpiderMonkey JavaScript engine. There's major efforts in place towards engine optimization for these use cases. It's a very basic JavaScript environment at the moment, but the goal is towards a full build your own JS runtime and make your JS runtime of choice to be able to create a programmatic, parameterized runtime builder. And it would be great to see what you all can do with it. So this is the setup slide. The basic setup is going to be Node.js for the JavaScript demos. The exercises repo is there. You can clone it already now. And once you've got Node.js installed, it's going to be clone that repo, run npm install in that repo, npm install g, ByCode Alliance Jco, and ByCode Alliance Componentize.js. And then to verify, you want to see that Jco -- is Node 11.2. And you can try that first test that I did at the beginning, which is Jco run char sa componentize. I'll bring this back up in the JavaScript group shortly. Look forward to seeing you in a bit.
Thank you, guys. All right, okay. Can you switch this on? Okay. Oh, wrong one. Okay.
Just a moment, please. Okay.
All right. So I've got the rough schedule up here. We're about to move out to our breakout rooms, but a lot of this is self-organizing. So I'd like to see a raise of hands. Who is interested in working on any of the Rust tooling? That's from with bindgen to WASM tools to writing your own Rust components. Rust folks? Okay. All right. So that means it's going to be here in this room. So you're lucky. You aren't going to be moving over to one of the other break rooms. Who is interested in working on the JavaScript tooling? I see several. Oh, okay. Okay, great. So you're going to be in Lawson. Yeah, you're going to be in Lawson. I just guessed based on size. Okay. How about Gophers? How many Gophers are in the room? We've got a Gopher crew over here. We got another one. Okay. All right. So you see each other. There's another room that's going to be Sonora. We're going to use that as one of our self-organizing rooms. So Gophers, grab a table like this. Please work together, or not. That's also totally cool. How about Python? Who's interested in Python? Joel, let's go. Oh yeah, Nashwarya, great. Okay, all right. So Python folks see each other. That's Joel Dice. Do you mind raising your hand again? Joel Dice is going to be our facilitator for Componentize Pi, tool he created. Let's see. There's more languages. There's lots of languages. Documentation. That's the most important one. Why is it always last? Okay, yeah. I see. Lots of people are interested in documentation. I see Ivan there. I thought I saw Kate earlier. Kate, shout. Okay, Kate's, you guys know what Kate looks like. So please get with Ivan and Kate. And I'm actually going to ask that you guys go in, well, yeah, let's do Sonora. And then if we need to, you go to Lawson, okay? I want to make sure that you have enough room because you guys were actually a pretty large crew. So you think so in here? All right, let's do that. Not to confuse anybody, I'm going to say it one more time. You're now going to be in St. Helens if you're working on documentation. Go people, I believe I said Sonora. The JavaScript folks are going to be in Lawson. Python folks should be in Sonora. Any others? Hey, is there something that I didn't say that you wanted me to say? C. Okay. Raise your hands for C. Okay, there's actually several. Okay, all right, great. C folks.
Also in here, I think, because closest to Rust.
All right. Well, we've decided that you're closest to Rust. You probably don't feel that way. So you're going to be in here. Okay. All right. Sounds good. Okay, so we'll help organize the folks in the room. Everybody online, we're sending out Zoom links for the other two rooms. I will post all of this, or somebody will help me post all of this in Zulip, and I think we're going to take about a 15-minute break while we start moving about.
Yeah, if the team leads could just come here, I've got a conference mic for you that you'll take back to your table if you're going to broadcast.
Oh, hey, we have a question. Absolutely. It's pretty rough. I will put something better for a little bit, probably. Maybe that would be easier. Maybe with where all the rooms are and where everybody's at. Okay. Oh, yeah. Okay. Or this? Sorry. Okay. Yeah, okay. One thing to know, even if you're not working on documentation, I think this is going to be super handy. We do have documentation at component-model.bycodealliance.org. It's also in the, I think it's labeled component docs, component-docs inside the ByCode Alliance GitHub organization if you're looking for documentation. And yeah, I could also pull it up. Hey, did you guys notice that that was the one that autofilled? Just saying. So it's extremely helpful. So even if you're not, in the documentathon of sorts, I still think that you're going to run into things, and then filling in for everybody else that comes behind you is one of the best things that we can do here. So, all right, we're going to take a 15-minute break.
Cool. One more thing.
One more thing. Okay.
One more minor thing. At the end of the day at 4 o'clock. We're going to invite people to give their own 5-minute presentations about anything that you've accomplished or learned today. So it'd be ad hoc, and we do have a couple of rewards for probably everyone who presents, because I don't know that that'll go there. So either everyone or the best 10, or maybe I have 8. So something like that. But just keep some notes. Just come up as an ad hoc demo. You get anything working at all. I think it'd be great to just draw a little attention to it. And we'll see you guys after break.
All right.
Can I do a quick thing?
Okay. There you go.
One more very quick thing. We have the Zulip stream. So bytecodealliance.zulipchat.com is our chat system. If you're in there already, you can just join. And there's a stream, aka channel, in there for this event, Componentize the World. And in there, any questions you have that you don't want to ask in person, obviously, if you feel like an expert is in the room who can answer your question, ask them. Feel free to always do that. But otherwise, ask in that channel. And also, please engage there. Don't wait for other people to answer questions. If you feel like, oh, I can answer this one, just engage there, answer questions as you see fit, and or ask questions and mingle in there. Thank you all.
Thank you. Okay.